Thank you for joining us. I am Brad Peniston. I'm the Deputy Editor of Defense One, and it is my distinct pleasure to welcome you to today's panel discussion, The Future of Navy Modernization, underwritten by Red Hat. Now, clearly, Navy modernization is a huge topic that could occupy many such panel discussions. We today are going to focus on the somewhat smaller slice of technology, and especially information technology, that stuff that is binding navies and naval forces together more tightly than ever before. So clearly it's something that CNO Admiral Gilday has been focused on with his Project Overmatch, and it's something that's helping to accelerate the whole sensor-to-shooter network effects, basically just everything having to do with warfighting. So before we get started, I'd like to go over a few housekeeping items. At the bottom of the platform, you will find several icons, including the Q&A tab, which will allow you, valued members of the audience, to ask a question. And we will be fielding those toward the end of the program. But feel free to submit them at any point along the way. And I'll be able to see them, and I'll be able to slot them into our discussion as we go along. So, joining us today, we have some terrific panelists. First, we have Stephen Knupp. He is a scientist at the Naval Surface Warfare Center Dahlgren Division. He's in the combat systems area, and his specialty is cybersecurity. We also have Brian Clark, who is Senior Fellow and Director of the Center for Defense Concepts and Technology at Hudson Institute. And both of these gentlemen have had fascinating careers, and I will let them tell you just a little bit more about themselves and what they're working on now, and then we'll get into a discussion about it. So Steve, why don't you go first? I tell you what, we'll come back to you, Steve. Brian, can you start us out?
You bet, Brad. It's great to be here. It's great to see you, and thanks for having me on here. I'm a retired submariner, and I've been a think tanker since I left the Navy about 10 years ago. So I've been working at CSBA, the Center for Strategic and Budgetary Assessment, since then, and also now at Hudson Institute, where I direct this new center. We focus my current research on defense operations and strategy and how new technologies are going to change them. We've done work recently on fleet architecture. I did a study last year that helped contribute to the Future Naval Force Structure study that led to some of the Navy's force structure decisions that you see coming out in the budget that you're going to see this year, as well as in the budget last year. We also do work in electronic warfare and did a study recently on that. And now I'm working on studies on maritime aviation and undersea warfare.
Well, that's terrific. That sounds like it's going to be a terrific contribution to today's discussion. Do we have Steve back yet? All right, looks like not quite yet. All right, Brian, let's start out. And I guess a good point of entry is just to note the vast changes that are happening in the way warfighting is being conducted. I mean, the Navy has a huge exercise coming up, the imaginatively named Large Scale Exercise 21, where they are going to try to put together a lot of these different concepts, distributed maritime operations, logistics into contested space, things that they've been working on for a few years now that try to take advantage of the networks and network effects, and they're going to try to put it together and actually do some sort of global live virtual constructive test of all of this stuff. What are you expecting out of that? Do you think that it's going to be do you think it's going to be all that they think it's going to be, or do you think that they're biting off more than they can chew here?
I think it's going to be an impressive effort. So the large-scale exercise is an effort by the Navy, as you said, to bring together some of the work they've been doing over the last several years in development of networks and development of new operational concepts. It's really admirable that they are pursuing some work to try to put this into action. And if you go back to it relates back to the interwar period between World War I and World War II, when we had experimentation that looked at like War Plan Orange and some of the ways that the U.S. Navy was going to try to address the challenges posed by the Japanese Navy. So those were translated into experiments they conducted in the real world to try to see if those concepts would work. So the large-scale exercise is supposed to provide that sort of starting point for a campaign of learning. So the idea is you build new operational concepts, You develop some new systems that support those concepts, like distributed maritime operations, and then they're going to take those to sea and see if they actually work in practice with some opposition forces acting against them. So it's an admirable effort. Tries to create this new cycle of learning, which is going to be a really important part to translating some really complicated ways of fighting and operating into something that can be actionable by sailors at every level of experience and sophistication.
Mm-hmm. Yep. All right. So that's kind of the big picture. What the Navy is getting ready to try to do. Let's drill down. You say you've been working on things like unmanned vehicles, and particularly you're very interested in the way underwater unmanned vehicles are going. Can you tell us a little bit about the state of play with unmanned underwater vehicles in the Navy now? What we're actually what we're experimenting with, where we hope to get with them, that sort of thing.
Yeah, so the Navy's pursuing a campaign plan on unmanned vehicles overall, which has surface, undersea, and airborne counterparts. In the undersea part, they're pursuing a family of undersea underwater vehicles that go from extra large, which is the Orca, extra large UUV, which is about the size of a small submarine, so about the size of a small diesel submarine from back in the Second World War maybe time frame. So 80 feet long to 120 feet long, depending on how you equip it. 9 to 10 feet wide, and it's going to be it could be like a payload delivery vehicle. So you can use it to carry mines, you can carry sensors, carry things into an area that would otherwise be contested, by things above the water. Then you've got a large diameter UUV, which they're going to deploy from submarines. So submarines will put this as a dry deck shelter that's carried on top of the submarine. That vehicle is going to be more of a adjunct to the submarine, so it's going to extend the reach of the submarine and be able to move systems into an area beyond where the submarine can go. So that's going to be a submarine combined capability. And then you've got medium UUVs, which are about torpedo sized. And those have been around the longest. So those have been used for a long time for things like bottom surveys. So searching for Malaysian airliner that went down in the Indian Ocean. Medium-sized UUVs were used for part of that bottom search. They're used for mine hunting today, and they're also used for being able to do some surveillance missions, where they can carry different sensors. So those medium UUVs are a long-standing area of Navy competence, and they're now getting their mission sets expanded to look at different surveillance missions where they can carry sonars and look for submarines, as well as being things that look for things on the seafloor. And then below that, you've got the small UUV category, which is maybe the most exciting category. And so these are UUVs that are maybe 9 or 6 inches in diameter and smaller. They could be carried by larger UUVs or carried by airplanes or ships. And some of the form factors that they would be in would allow them to be launched by the 3-inch launchers on a submarine, by the sonobuoy launchers on an airplane. They could be launched or by a helicopter. And they would be able to provide some interesting range of missions. So, for example, they could be sensors, so they can have little sonar arrays on them to do surveys. They're not very powerful, obviously. They don't have a very long range. They could also have passive sensors on them, so they could record what's going on in the ocean environment, whether that's natural phenomena or potentially a submarine. They can also do things like jamming. So they could do acoustic jamming or acoustic decoy missions. A version of that is being used today by the Navy called the EMAT. So it used to be that if you wanted to go and trail a submarine and practice your ASW techniques, you'd have to get another submarine to do it. So over time, we built up this target capability, so you could have something that simulates a submarine. And so today, the EMAT does that, and it's in this small UUV category. So that can be turned around and used as a decoy if you wanted to in an overseas kind of contingency operation. So that you have this family of UUVs that have a growing range of missions and that are going to be applied in this. Some of these are going to get applied in the large-scale experiment. The Navy recently did an unmanned experiment where they combined unmanned systems from various domains, including some of these UUVs. And I would say that the most interesting part of the UUV mission set is that the fact that they're going to allow to taking people out of some of these operations. So by turning the mission, for example, of mine laying over to a UUV, you can keep people from having to go into some, very shallow waters or contested waters. By using UUVs to do mine searching and mine clearing, you take people out of the minefield, which is always good. And then by putting sonar sensors on them to look for submarines, you can allow this unmanned system to do the kind of the mowing the grass or the back and forth survey missions looking for submarines coming through a choke point that we would have used to have a manned platform do. So it really lets you scale the force in a way that we haven't been able to do before and reduce the risk to personnel in a way that we haven't been able to do before.
Mm-hmm. So a fascinating array of new capabilities and new possibilities for undersea warfare. How do these things get command and controlled? It's one thing to have, as you say, the Navy's been working with sort of maybe mid-size UUVs for a long time to go find things underwater, and it's easy to conceive of something that you could program to do a bottom survey. That's fairly easy. But something like the payload or the sensors that you might want to fan out and do cross a large swath of water, or maybe even have sort of dynamic tasking. They see a seamount and they go around it, or they hear something, they want to go follow it. What's the command and control aspect of all this look like?
Yeah, so that's a great question. So there's a couple of aspects to it. So the Navy's developing a common control system, which they did use for some of the under the unmanned system experiment demonstration they did a couple months ago. And there's also, so that allows you to be able to talk to these systems, get information from them, in whatever timing that they can achieve. So some of them aren't real time, right? Because if it's undersea, it's got to come up and be able to communicate with you. But this common control system allows you to program in a mission, send that out to the vehicles. The vehicles perform the mission or aren't, and then able to provide you feedback as to whether they did the mission, and also provide back some of the information they were able to gather if that's what their job is. The other part of it is the mission planning, and so probably the most exciting area is the use of artificial intelligence and machine learning to be able to help guide the ConOps development and the mission planning for these unmanned systems. Because ideally, you wouldn't want this to be a static process where I plan out the mission, they go off and do it, they all come back home, I reprogram and send them back out. I'd like to be able to dynamically plan them based on what my opponent is doing, because I'm trying to also create some complexity and some dilemmas for my adversary. So I want the ability to have a mission planning system that is understanding what my opponent is doing, plugging that in, and coming up with some courses of action that it can propose to me as the operator to say, well, it looks like your adversary is doing X, Y, and Z, or it looks like I'm picking up submarines here, or I'm picking up mines over here. This is what I think, some options are that might be more effective to, pursue the objective that you've identified. So I think there's the two aspects of it. So it's the communication with the vehicles themselves using this common control system, but it's also having the ability to do this essentially AI-enabled decision support for the operator to be able to better exploit the capabilities that those unmanned systems provide based on real-time feedback from what your opponent's doing.
Mm-hmm, mm-hmm. So the AI in this case would be a resident probably on the vessel or whatever platform you're operating this from, and it's something that then talks to the human operator who says, here are the options, let me do it. Are there also efforts to make the UUVs themselves smarter, to be able to look at what's going on and dynamically figure out what their next move might be independent of human control?
Absolutely. So the AI or machine learning has been used for a little while in terms of for sonar systems to do automated target recognition, to understand what a combination of noises might signify. Is that a set of tonals from a submarine? Is that sea life? Is that seismic activity? Or is it just background noise? Is it a merchant ship? So we've used machine learning for a little while to do that, and that's been being advanced. So that kind of capability is what you'd want to put onto unmanned vehicles that are doing anti-submarine warfare searches, for example, so that they're not radioing off every piece of information they receive, but instead they are gathering sonar information, determining if they have a contact, and then sending off that contact report to you when they're confident they've got something worth pursuing. Also, you'd want to incorporate some level of machine learning into the control system, so that if you'd say, go off and lay a cable over here, put a mine over there, they can avoid contacts by using their own sonar, but they might also need to be smart enough to recognize when the adversary is trying to create obstacles to prevent them from reaching their target location. Because once this gets into a competition, you could expect your adversary to say, well, I'm going to do something to prevent UUVs from dropping mines in my harbor. So you'd want a machine learning system to be able to recognize when you're being actively fought against or actively thwarted, and come up with a way to compensate for that, or a course of action to be able to countermand that. So there's ways to use the artificial intelligence on the vehicle, both in support of its sort of surveillance and targeting mission, as well as in its control mission to kind of reach an objective it's trying to achieve.
Great. And I'm sure that Steve Canup is working on these sorts of decision aids over at Dahlgren. I am informed that he's back on the call. Hey, Steve, are you there?
I am. I apologize. A little bit of user error / technical difficulty on that part. But yeah, if you don't mind, I want to say thanks for the invite for this and stuff. And just kind of like mentioned, my name's Steve Canup. And I currently work for one of the Navy's warfare centers. You mentioned specifically Dahlgren Division, located in Dahlgren, Virginia. And my primary focus area is in regards to cybersecurity and how it applies to combat and weapon systems for that. Just to kind of back up a little bit at a high level, just to kind of explain what a warfare center is for the people on the line. It's really the technical arm of the Navy. It's what the warfare centers across the Navy basically is a avenue where the Navy itself reaches in to build build capabilities, whether it's designing the requirements before they go out to contractors, or actually helping with integrating or building those particular parts and pieces on that part. And so performing, really, if you had to say what we do as a whole, is regardless of the Warfare Center, is we're performing system engineering functions for either existing or future technologies on that part. I also think in regards to the purpose of this particular brief, being a Navy modernization, it kind of coincides a little bit with Dahlgren. Just recently, we've updated our 5-year strategy for 2021 to 2026 on that part. And really, within that strategy, there's various things, but there was one strategic area, which kind of the first one, which focused on what in the next 5 years, we're going to focus on in regards to our technical thrust. And there was 5 of them also. The first one was intelligent automation. Second was software engineering revolution. Third is digital engineering. Fourth was hypersonic weapons advancement. And the final one was information superiority. And just to kind of give you a quick blurb of what those are. Intelligent automation, really, we're in an environment where we have near-peer adversaries in regards to that area, that subject, and how we use it. And really what Dahlgren's going to be focused on is how to become the Surface Navy lead for intelligent automated warfare systems. And what I mean by intelligent automated warfare system is really that intersection between autonomy, artificial intelligence, and unmanned systems. The second one was the software engineering. So that's in some ways just like the intelligent automation, an enabling technology that we have for that. And what we want to do is move from our traditional development of how we do software, where it has a lot of rigor and high quality products that to high standards that we produce. We want to really inject into that rapid development of it, rapid development and rapid use of those, and get that technology out quicker than we have in the past. So it's really focusing on that. The third area was digital engineering itself, moving from that traditional engineering approach, which is kind of in some ways outgrown how we do engineering now due to the complexity of how things work and interact with each other. So we need to start moving to that digital engineering to do faster development, to actually continue with the high quality development of what we do with it. The fourth one is hypersonic weapons advancement. That is a very competitive in the world area within the world, and not just in defense, but in offensive form. So our basically focus over the next 5 years is really to establish as a national hypersonic technology presence. This includes aggressively pursuing new defensive systems, but also for the offensive systems, we'll expand Dahlgren's role in development and establishment of the railgun as the national asset for testing. And the final area was the information superiority, which is really kind of focused on getting the right information to the right hands to be used. I mean, that is the lifeblood of a combat system, is that information. Information is combat power, is a motto that goes out there. And so really this is just leading the warfare system development of that future naval network infrastructure and making sure that it takes in consideration just not traditional C2 functions and stuff, but also the requirements of combat systems for it. So if you kind of remember, I mentioned at the beginning I was kind of a cybersecurity guy in regards to this, and you may wonder what that has to do with those thrust areas. I think those thrust areas give you an idea of where Dahlgren's going, which in theory kind of gives a hint where some of the places the Navy's going on that part. Cybersecurity itself is actually an ability or an enabling capability for all of those areas, whether it's helping with the systems engineering or the digital engineering as characters, but also kind of building those resilient systems in themselves, whether, for the information superiority, securing the data and the networks and stuff that goes through it, but also from the hypersonic in regards to building it securely on that part. And from what we at Dahlgren do in regards to cybersecurity, to give context also, is because that's a wide field and a lot of subjects on that part. So first of all, I'm focusing on defensive security, and specifically, it's really what we're doing is integrating. As you mentioned, if you remember what I said before, we were kind of systems engineers, or what we do, system engineering. This would be the integration of cyber engineering, those tasks and functions within that system engineering processes on that part. And so really what we're trying to do is when we build these systems, also build them cyber resilient, a phrase that a lot of people use. We're defining it as we want these solutions of these systems that we're building to be able to perform their missions in a cyber adverse environment on that part. And so there's a certain set of capabilities as far as building those to testing those and deploying, sustaining those. Also, we do develop focus on GOT cybersecurity. Those are the rarer case. We tend to focus on using the COT solutions that exist out there and building on those. And only in the cases of where something that the commercial world or industry, academia has built that doesn't work in our environment for some reason, will we pursue a GOT solution for that. And there are some cases for those. And it's not that the commercial world couldn't figure it out or work on it. It's probably maybe there's combinations of marketing or the niche is too small, or specific in that part. So those are the two ways that we kind of integrate that resiliency into those systems on that part. And that's the wrap-up spiel for that.
Well, that was just terrific. That was a ton to chew on. And Brian, I'm going to let you ask some questions in just a second. I'm sure that that generated a whole bunch in your mind. But Steve, let me start with a human-focused question. All right, it's all great to create AI-powered decision aids, and maybe it's great to have a bunch of options pop up on your computer. But the Navy is not alone in trying to grapple with the idea that how do you convince a commander who has lots to think about and maybe doesn't trust these machines? How do you build that trust that enables all this terrific technology to actually be used and come into play? And Brian, as a retired submariner, I'm sure you have some thoughts on this as well. But Steve, tell me about that aspect of things.
Yeah, so and I'll put a cyber flare on it, because in some ways that's a part of the decision making. Those are some of the decisions that a commander would have to make in regards to that. And from my perspective, the approach is we're going to be taking basically is layered. In other words, it's not one day from no decision making to 100% automation, in those decision making. So I think in some ways what we're trying to do from a cyber perspective, which is confident can relate to the other areas, it's more of a confidence value. In other words, if I'm having something happen with my system in regards to it performing its mission from a cyber resiliency perspective, we're not going to present them with data that says, hey, you got a virus here, you got this problem here, you got whatever. We're really going to roll it up to the check engine light scenario and kind of give them confidence on whether that system, what its state is and ability for that. They can then use that information to make decisions on whether to continue the mission, stop the mission, or alter the mission and stuff like that. So really, it's kind of a step-by-step. In other words, starting off with what we have with our traditional decision aids, some of them manual and stuff, adding automation to those to help with the complexity of those, and providing that. But right now, in the near future, a lot of the stuff that we're focusing on does consider as far as the deploying part, is usually there is a HMI part of it, a man in the loop for it.
Gotcha.
Yeah, Brad. So it's an interesting area. So we've done some work on this for DARPA, looking at this human-machine interface for automated systems, automated decision aids. And as a retired submariner, I'll say one of the things you need is some track history. So I think the first time you use Google Maps, you're maybe unsure of whether to follow the course it's giving you to follow to get to your destination. And then after you use it a few times, you're off to the races and you're fine, just trusting it no matter where it takes you. And so we see a similar dynamic occur with regard to these decision aids. Is you got to use it a few times and get confident that the information it provides you is useful and that it pays off. Another thing is is explainable AI, so the ability for the system to give you some sense of why it's making the recommendations it is. So a little bit of kind of background to say, well, here's the course of action that here are some courses of action, so you can choose among them. But then within a course of action, you can explain, well, here's the communication network that we think is going to work in this situation. This is what we are depending upon. Or here's the target we're proposing that you go against, and this is the weapon. And you as a commander would have enough understanding to be able to judge whether that makes sense or not. So you always have to have that human in the loop to check on that because, one, just because there's legalities involved there, but two, because in a lot of cases, these AI decision aids are going to propose things that maybe from a practical perspective aren't the best way to go. Another thing that was interesting in some of the work we've done, in my experience, has been you could choose something that's optimized for the near term. So you could choose a course of action that will work really well for the situation you're presented right now. But as the commander, well, if I do this, I'm going to use up this resource that I'm not going to have anymore. I'm going to put this ship in a position I'm not going to be able to reallocate it to a different mission down the road. So I'm cutting off options down the road if I pursue this thing now. So I'm going to take a less optimal action now because I want to maintain my options open down the road. So those are some things that the human has to think about, which is why it's important to get the human and the machine working together as a team and understand what the limitations of the machine are. And also the machine will start to learn that it needs to be thinking ahead, just like the commander is.
What do we think the timeline is? Steve, you mentioned that it'll be a gradual rollout. It won't be a flip the switch and suddenly you've got, an AI buddy next to you on the bridge. What comes first and when and then what and then what?
Sorry, pushing the wrong buttons again. Sorry. Yeah. Hey, good question. And to be honest, I don't have a timeline for that. But in regards to different subject areas, I think the obvious way a lot of these things will be, for example, decision aid, things that are complicated as far as drastic in regards to those. I want to say simpler technologies, or in the cases of where the decision is wrong or the analysis produces wrong, it would be more of a, starting with those depending on what the impact of that is. So probably starting off with those sooner than later. Training comes up with a lot of cases in regards to that for it. And also in cases of where the decision doesn't have to be 100%. And that's hard. And the reason I stutter on that is because definitely we struggle with the actual combat and where the air budget isn't that high on that part. So I think it's a lot of the ancillary stuff that's around that area and applying to that. And as we gain confidence in being able to use that data, those capabilities for it. The other challenge is actually data. These things need a lot of data to understand and how to work properly and stuff. And I do think that's an area that we struggle with some places more than others. Not a great answer. Apologize.
Well,
Brad, I will say that. Yeah. Oh, go ahead, Brad.
Oh, no, I was just going to say, the Navy isn't alone in more data. There's a conversation going over in the Army right now. How do we bring AI, out to remote bases and remote operations where we don't have, a good connection, where we don't have really powerful computers with all-day batteries? How do we get the stuff out there? So it's a common problem. Anyway, Brian, sorry, go ahead.
You're seeing, that is the challenge, and then, but we're already seeing some of these systems begin to emerge in mission areas like we're saying in the less time critical. So in anti-submarine warfare, for example, we're seeing some of these systems come out because it progresses pretty slowly. It's easy to keep a person in the loop, and you can sort of take a look at what the system is proposing to you in terms of a search plan or in terms of what targets it thinks it has found, and judge that and determine whether you think it makes sense or not. So in slower areas of warfare, you're seeing these systems start to emerge. In the Project Overmatch experiment, they used a kind of primitive version of one of these decision aids. Aegis has some of these decision aids built into it. So I'd say these systems are already here, and some of them are already fielded. And then the question is, how comprehensively do they understand the situation, which gets to the data problem? So they might have a kind of a blue perspective on what's going on and really not understand what red's doing very much. And also, as you go into faster areas of warfare, you don't have this ability to keep people in the loop as easily. So maybe those systems have not yet emerged in those faster areas of warfare like air and missile defense. But you're seeing these decision aids start to come out and be used, and it's just these are kind of the primitive early versions of them, and they'll improve over time. But I think, like you said, data is one of the biggest challenges, especially data about red forces, which in many cases for the work that's going on right now, the commander has to estimate. So the commander has to make some judgment as to what they think red's doing and program that into the system.
Mm-hmm. Steve, you were talking about building cyber into everything you do, or not building cybersecurity into everything you do. And, obviously, or maybe legendarily, the internet was built pretty much without regard for security. And that's the cause of a lot of problems we have now. How I presume as well that in the Navy, network security was not always the top priority, just because the threat wasn't so great, and the ability to attack just about anything wasn't so great. Has there been a revolution in the way that the Navy looks at cybersecurity, or has it always been better than I'm making it out to be?
No, I mean, in some ways, I'm going to say Navy, we'll call it weapon system, combat system. At the beginning, back in the 80s and stuff, we kind of built our own OSs, and we built our own hardware. We built everything, and we only built in the functionality that we needed on that part. Did we know anything about this concept of cyber and stuff like that? No, we didn't, but we did have a lot of other abilities, reliability, maintainability, those things that help contribute to that. Jump forward some time, the world of COTS comes out, and we jump into the arena of kind of pulling in COTS. And one of the challenges with that is we pulled in a lot of functionality that we didn't necessarily need. In other words, I needed to be able to push the button to turn the light on, but the COTS capability gave me 4 other options also that I didn't need. But we took the approach of that was okay because it did what we needed. What it ended up producing was we ended up resulting in systems that had some functionality that we didn't need. And every bit of software, whether we're writing it, whether the industry is writing it, it will have vulnerabilities. And people struggle with that, and the Navy is no different than the commercial world in regards to this. But the one thing that we inherited from doing that is we picked up all that extra software, all that extra functionality that we don't use, which contains tomorrow's vulnerabilities. So in regards to what now our revolutionary change, and there's a lot of areas, and this is just one area that I'm kind of looking at, is really kind of implementing the least functionality rule and least privilege. I think those are 2 key foundational kind of principles for cyber engineering in the system. One is get rid of all the functionality that you have. It will not, so that you don't have those vulnerabilities that you don't need, and get rid of those. And then in turn, just focus on restricting the access to those. So if things are cracked at one level or another level, you're kind of putting them in a sandbox, for lack of a better word. So that is where a lot of things, whether it's ONR that has been working on task, or us in building capabilities, or just our traditional engineering on how we kind of restrict what we put in our systems. In other words, don't put all the COTS capability out there. Put only what you need, and actually look at technologies that will just strip out even other functionality that you don't need. So it gets right back to, I'm going to call it a piece of COTS that's been specialized for our specific need on that part, but yet it's still a traditional OS or a traditional piece of middleware and stuff like that.
Is it getting harder to strip out those capabilities? My very non-expert take on this is that, if you look at things like Apple laptops, used to have a jillion chips in a laptop, and now you have 3, because the CPU now does 75 different functions, including encryption and all this sort of stuff. And I would imagine that if you're going to try to strip something out that, you'd find it very difficult. Is that is that in any way a relevant frame on this, or am I way off base?
No, I think a lot of times you'll see where the dynamicness in software, or even like firmware and stuff like that, it's usually, for example, you'll write firmware for a particular system, and it may handle 100 types of or 1,000 types of hard drives, when in fact your system only is using one type of hard drive. So it's not so much as stripping that out. The act of stripping it out is hard, and people have been coming up with recent technology to help do that. Also, in regards to OSs and stuff, they've gotten smarter at basically, rather than saying, here's this monolithic thing that has 1,000 things to it, here's a set of packages and services that you can kind of tailor it for what you need. I like to kind of equate it to when you used to buy a laptop and it came up with a bunch of freeware, so to speak, and stuff that you didn't ask for. good practice is to get rid of all that stuff. You don't need it, don't add it on there. Same concepts for us in regards to the software. Obviously, I'm not talking about GOTS software. When I mean GOTS, aka software we write, in theory, we only write what we need. It's when we add the layers of the COTS, whether it's networks or switch layers, or if it's the OSs and stuff like that, and really ripping those out. In the cases of where maybe the mission is extremely important and stuff, we do think about pursuing specialized versions of those OSs, or even OSs that have been formally tested and formally verified and stuff like that, and pulling those into it. But it's a combination of, you're never secure 100%. You just want to secure it as appropriate as you can. It's a balancing act on that part. So you shouldn't look at it as, hey, I'm going to take out every vulnerability I have. That part that's not realistic, or I'm going to secure it such that it can only do what I want. You want to kind of do what makes sense for what you're building on that part. Right.
Yeah. What did they say? The only secure system is like a brick that sits on your desk, and you can't do anything with it, and you can't access it, and that doesn't help anybody.
Yeah, and that's becoming easier to do.
Gotcha. Okay. Let's turn to a couple of questions that are starting to come in from the audience. This is an interesting one, and maybe for both of you, as a matter of fact. The question is, how can you determine if the enemy is trying to deceive your sensors by putting out deceptive information? And of course, this is an age-old problem of warfare, and deception has always been a problem of warfare. But now we have things like, deep fakes, where AI, looks at what you think it should, what you think it should be seeing, and create something based on what you think it thinks it should be seeing, and you just get this, crazily realistic, scenario in whatever area you're looking at. That's terribly hard to figure out. How much does that figure in what you do, Steve, and what's your take on it, Brian?
So good, Steve.
Oh, sorry.
Sorry, I didn't ask that very well. Who wants to go first?
Yeah, I'll go first. It's Steve. First of all, when I hear the word sensors, from my perspective, I'm thinking sensors for our combat system. And typically those are in the RF realm, or over the traditional networks and stuff like that. I would argue at the network level, traditional, it's not much different than finding other bad data that comes across people's generic one. Obviously, the more specific the type of information, the more tailored you can do your, we'll call it detection of whether that's good data or bad data. In the case of RF and stuff, we do deal with those, but in turn, that also what we intersect with a lot of areas, what we call EW on that part. And so a lot of that is the same business as usual, but obviously we do things, we do data transfer also, not just raw sensor data. And for those, it's typically starting to move towards things where not only is it, let me back up a little bit. It's not, from the cyber perspective, we don't always just look at it as someone trying to fake us, but it's also in the cases of where it's just accidentally misinterpreted. Look a lot of times at those as being very similar from a cyber perspective. In the EW world, no, they have a little bit more specific guidance in regards to, or targeted in regards to malicious or counters and stuff like that.
Gotcha. Brian.
So EW is a great place to talk. I mean, in the EM spectrum, you can generate decoy signals. You can try to emulate an emitter that somebody's trying to look for. So as the receiver of that information, how some ways that we might go about trying to determine real from Memorex is the overall signature. So also this happens in the undersea domain as well. Is you look at the overall signature and say, well, I'm only getting this one frequency from this thing. And I'm not getting any of the other frequencies or emissions that I would expect from this object if it were really the thing it's trying to pretend it is. Also, is it, and then the context clues of, is it moving in a way that's consistent with the way this thing would normally move? And actually, in some cases, am I getting a dirty signal, which would be reflective of a real thing in the real world, or is this signal really clean, which suggests that maybe it's an emulation rather than an actual product or actual system? So those are some things you can do in terms of just the signal itself. There's also the kind of the greater context clues of, if you've got a decision support system that's helping you, and this is even possible with today's systems, does it appear that this is an operation consistent with what else is being done by the adversary? So are they showing me a submarine, but it doesn't appear like any of their other platforms are operating in a way that would reflect there being a submarine there? Like, are they driving over the top of their own submarine, meaning they're not, coordinating with one another? Or are they operating in a way that's going to put that submarine at risk, operating their sonar in a way that would put their own submarine at risk? So things like that. So context clues. And then the last thing, which is something kind of the newest area where we're looking at, is you could probe. So you could say, well, I'm getting a indication here that this is what the force looks like, but I'm concerned that there may be deception involved. I could probe that by sending a electromagnetic or a sonar emission toward it to see if it reacts in a way consistent with a real object. Or I could send a physical, I could send a UAV or an unmanned system over there to investigate and see if it reacts. So there's ways to probe and try to do that, that's why one of the reasons why it's so important to generate this other part of the force that's this unmanned part of the force with more attritable and expendable objects that they can go in and do some of these probing missions that would allow us to kind of test out whether what they're presenting to us is in reality what's happening.
Gotcha. Well, we just have a very few minutes left, and I just wanted to touch briefly on one thing that you both mentioned, and I think is kind of a hot button topic for anybody looking at modernization: hypersonics. Steve, what can you tell me about what Dahlgren is doing with regard to hypersonics? I can see his finger inching hypersonically toward the mute button now. Or maybe we just lost him. All right, Brian, you mentioned hypersonics. What is what's around the corner?
So you can see there, we've got a couple of, there's hypersonics in a few flavors, right? So there's the boost glide weapons, which are the surface launched weapons. The Army is building out a couple brigades. They might build more brigades of those weapons or fire batteries. So there may be a few batteries of those long range hypersonic weapons. They're relatively expensive. So you're not going to have a huge number of them. The Navy is pursuing those as well. They're pursuing a common booster for those two weapons and some common glide bodies. The Navy's version will go on either surface ships. They're looking at the DDG-1000 as being a host vehicle for that boost glide weapon that would be launched from the surface, or potentially the Virginia-class submarines, the Block 5s with the Virginia payload module. But that's a little bit more of a lift, right, because there's more engineering involved to put that onto the submarine. And have it be launched from the submarine as compared to launching it from a surface ship. So it'll probably go on a surface ship first, and it probably will be a DDG-1000. And so those weapons are pretty expensive and large. So you might have a relatively small number of those that are in the force. So maybe 100 or 200. And then you've got another flavor of them, which are the boost glide weapons that are launched from airplanes, which are a little less expensive because they don't require the same booster to get up to that altitude. The Air Force has those. An example of that is the Arrow program. So there's probably a larger number of those. Those are pretty far along. They're not as mature as the boost glide weapons from the surface, which are going to show up here in the next year or two. And then you've got the last flavor, which is an air-breathing hypersonic weapon, which essentially launches as a normal missile and then brings itself up to hypersonic speeds using its own engines and transitions to using like a scramjet engine that can operate at hypersonic speeds. That's really the target that DoD is driving for, because those are the missiles that have the biggest potential to get down to a price point that's kind of like that of conventional missiles. So if you can get the price point of a hypersonic air-breathing missile down to the $3 to $5 million range, and now you're talking about a missile you can buy in numbers, more like what you would buy a JASSM or an LRASM in today. So that's really the goal DoD is driving for, is to eventually get to this air-breathing hypersonic weapon that you could launch from ships, aircraft, and buy in numbers to present this challenge to an opponent of a weapon that's really hard to shoot down and gives you that time on target that's really short.
Right. Okay. Thank you. That's a great overview. Steve, do we get Steve back? Yep. I guess not. Well, I think Oh, hey, Steve. Yeah. Great. Excellent.
He is still challenged with the mute button on that part. Hey, unfortunately, I don't have anything to add to what Brian definitely went over. My experience with hyper velocity is very limited. I'm more in regards to, as I mentioned, the cyber in regards to for those systems. But as far as the science and the plans for those, Brian pretty much hit the nail on the head.
Good. Then I think we will close there. We obviously just scratched the surface of a tiny fraction of what we might have talked about for naval modernization, but I do appreciate very much Stephen Canup and and Brian Clark for coming on and talking with us. I hope that everybody else has found this useful. I know I certainly did. One last question for Steve. I have people asking, hey, where can we find this Dahlgren 5-year plan? Is that on the Dahlgren website? Can they go there and look it up?
Just let me check.
All right. Well, while Steve looks that up, I'm going to welcome everybody to stick around for a few minutes. Red Hat, our underwriter, has a message for everybody. Last word to Steve. What does it look like?
This feedback. Hey, yeah, supposedly I can't make that available. I'll have our people call your people so that they can figure out how to make that available.
That's great. Okay, then everybody should come over to Defense One. We'll put it in debrief. We'll let everybody know about that. All right, Steve and Brian, thank you so much for joining us, and listeners, thank you for watching, and stay tuned for our underwriter. Have a good day.
Thanks, Brad.
Thank you.
Big thank you to our editorial panel. Hello, everyone. I'm Daniela Fair, publisher at Defense One, and it's my great pleasure to continue the conversation with Phil Ossip, DoD Solution Architect at Red Hat. Welcome, Phil.
Howdy.
Phil, I'm looking forward to talking to you today, but I wanted to ask you to spend just a moment telling our audience a little bit about yourself and your role at Red Hat.
Sure. So real quick, I know that this is a Navy focused. I'm a former Army NCO. I have a strong software architecture background and have been working to try and solve contemporary issues within and across the DoD. I've had the pleasure of being able to do that across service over the past 25 plus years.
That's terrific. And I think that really helps set up our conversation here so that our audience knows where you're coming from. So let's just get started. I wanted to ask you first, what are some of the main reasons that you think, for why the Navy needs to modernize and innovate as a force? What are the priorities here?
Sure. So I actually cast this into sort of 3 high-level reasons, and it's not going to be rocket science here. Who we fight is changing. So in the past, we have not had a near peer or peer adversary conflict to have to contend with. And that's no longer the norm. We have a near peer or peer adversary. How we fight is changing. So we're not running and executing and prosecuting missions on the battlefield as a single service. There's a joint or multi or all domain dimension to all of this. And then where and when we're fighting is changing. There's a need to be able to do things distributed in a way like we've never had to fight before.
So let me ask you if you can expand on the specific challenges within that. That makes a lot of sense, what you're saying. What challenges the Navy must overcome as they attempt to adapt and innovate, and address that in a, more specifically.
Sure. So in typical military operations, it's all about compressing the OODA loop, the observe, orient, decide, and act loop for decision making. I would suggest that one of the key challenges for the Navy for adapting and innovation is applying that same sort of OODA loop compression to the acquisition cycle. It's not just an operational focus, but in order to be able to be adaptable, to be innovative, to be agile, is to be able to do things not only quicker than we did them before, but do more with less, do them in a decentralized way, be able to distribute them. And then while speed is important, if it's not coupled with accuracy, visibility, observability, and organic decision-making, we haven't really helped. We've made things faster, but we made existing things faster. We didn't make the new need. We didn't address the new needs.
So as we progress down this road for the naval modernization, how would you define success here? How can this be measured? What are ways that we can measure it?
So there's all sorts of metrics that can be applied, and I think it's important in the context of the Navy and DoD at large that we focus on operational versus technical or contractual MOEs, measures of effectiveness. We want to score ourselves based on the utility and the mission outcomes that are being addressed. This brave new world of multi-domain operations requires that we don't simply maintain metrics for metrics' sake, and we have the warfighter in mind all the time. And that's not to say that we don't maintain metrics for defect density and normal things you do within the software development lifecycle. I'm saying to be successful, you don't score yourself myopically on those sorts of metrics, because that will drive behavior. And if all you really care about is the development side of the house and metrics for that, then everybody will focus on generating really nice metrics for that part. We need to keep mission focus and mission outcomes our top priority. And we score ourselves based on our ability to achieve those objectives in a more timely, more secure, more adaptable fashion.
What are some of the best practices that you've seen to enable effective transformation strategies?
I put 5 really high-level ones together, but really the first 2 are the most important. The very first one is start now. Just start. The potential for analysis paralysis, the potential for trying to figure it all out ahead of time before you transform anything is killing us currently. So start now and start small. That's number 1. Second on my list would be addressing the cultural hurdles first. And you can use technology as a proof point to show the way. But this isn't a technology problem. This is a paradigm shift in how we've historically operated. So if there's no change to status quo, technology will, again, make things faster, but not necessarily make things better. So addressing those cultural hurdles is essential as a best practice. It's not just about chucking technology against the wall and seeing what fits. It's about actually changing mindsets, building collaborative groups, and that's a Red Hat focus with open organization. It's something we eat our own dog food. It's what we do internally, and we promote it externally as well. I would suggest number 3 would be sort of take an on-ramp approach. Don't eat the elephant in one bite. So that on-ramp approach versus a big upfront design approach, this is a journey. The Navy in particular has a lot of brownfield. There's a lot of existing things. It's not all greenfield new. You can't just transform by doing a line in the sand and everything else to the left is dead to you, and only the stuff on the right is all new and shiny. We have to take effectively old and busted and keep it working with new and shiny. Number 4 would be plan, but be flexible and not rigid. And that's towards the transformation strategy itself. You do want to plan and be very rigid with mission capabilities. You don't want to have a weapon system that's not fit for purpose. You don't want to have a collector that's not fit for purpose. But if we think we understand the modern battlefield 5 years from now, perfectly now, we're lying to ourselves. So there has to be flexibility built in so that transformation itself can adapt. And then last one, it really ties into the last question you asked. It's metrics are essential. Peter Drucker's got a great quote: "You can't improve what you don't measure."
Phil, so since you've spent a portion of your career in the military and also in industry, what collaboration between the two do you think will be required to deliver advanced analytics and to accelerate this innovation?
I think for real acceleration and for real delivery, we need to focus on the how and why aspect with military and industry partnerships versus the what. Talking about what technology or what singular approach, tech's moving too fast. Everything we're doing right now is going to change in the next 6 to 18 months. It's that quick of a movement, especially when you're talking about analytics and innovation with things like AI and ML. So we want to focus on being able to bring in collaboratively insights from industry on how and why they're applying technology for other vertical needs, whether that's in a financial space or in a transportation space, because there's natural collaboration or at least joining of those thoughts to missions within the DoD and within the Navy in particular. The other thing I would say is that we've got a good start with things like OTA level experimentation, but being innovative is different than demonstrating innovative technology. So we really need to work with military and industry to collaborate on roadmaps for iterative development, vetting, alignment, and delivery. Too often we focus on the ends of those spectrums. We make development work really fast, or we make delivery work really fast, but we don't put it together. In order to effectively advance acceleration, it has to be a soup to nuts sort of thing. And that means collaborating soup to nuts.
Phil, we've covered quite a bit in our short time together today. Do you have any parting words that you'd like to leave our audience with today that we didn't cover?
I do. I want to reference another Peter Drucker quote, and then I want to do a quick Italian food analogy. So the Peter Drucker quote is, if you want something new, you have to stop doing something old. Looking at this as purely an additive experience. I have what I have now, and I'm going to continue to add on to it and add on to it and add on to it, is comforting, but it's ultimately untenable. And the Italian food analogy I would make is with spaghetti, lasagna, and ravioli. So in industry, there's a term spaghetti code. You started with something that was very clean and understood. You added to it over time, and you added to it, like putting more and more spaghetti on your bowl, until it becomes just a jumbled mess. So spaghetti is increasing your technical debt. It's adding complexity, and over time, it's generating brittleness. So what have we done historically? Well, we've gone to lasagna. We've had a nice, neat, traditional layered approach. So I'm going to do my data stuff, and then I'm going to do my business logic, and then I'm going to do some user interface work. Well, that lacks scalability, and there's no well-defined separation of concerns from a mission outcome. We've got it from a technical thought structure, but not from a mission thought structure. So ravioli, or gnocchi if you prefer, have independent capabilities and services, and they're interconnected. So you could think of the different sauces on your plate as the different services or branches of service or domains within multi-domain operations. So I might have a pesto in one case and a tomato-based sauce in another case, but I'm using the same ravioli and gnocchi. I get a software reuse. And ultimately, I just want to close with, if we want to be successful, start now.
Phil, that may be the very best analogy I have heard in my career here at Defense One. Thank you so much for your time. My Italian heritage also appreciates it. That's all we have time for today. I want to thank Red Hat for making this event possible, and I want to thank our audience for tuning in. For Defense One,
Thank you, Daniela.
You're very welcome. For Defense One, I'm Daniela Fair.